Hello students, this is Nilanjana Sanyal from onlinemathtutor.me and ePortion. Today we will be learning about the division of a line segment. So let's start. To divide a line segment in a given ratio. Given number 1 point is a line segment AB. This is the line segment AB. And we have to divide this line segment in the given ratio, that is 3:2. The ratio for division is 3:2. Now, the steps of construction. We have to construct. We have to get the point on this line segment AB so that that point divides the line segment AB into two parts in the ratio 3:2. For that, first of all, a ray ET is drawn, making an acute angle with AB. So this is the ray AT and this is the acute angle. Now taking any suitable length, say 1 centimeter, I have given this as an example. You can take any length of your choice which seems to be proper for your diagram. We draw 5 arcs. Why 5? You just add these two numbers. Whatever ratio is given to you, you add the two numbers to get the number of arcs that are to be drawn. Over here, since the ratio is 3:2, we will be drawing 5 arcs. 3 plus 2 is 5. 5 arcs are drawn on the ray AT starting from point A. So what you have to do is you have to place the compass pointer needle at point A, and with any suitable radius you have to construct 5 arcs on this ray AT. But to show that same thing, I have taken the help of a particular small line segment. So this is the line segment that I have taken. And this is of course more than 1 centimeter length. It is not necessary that you have to take the radius as 1 centimeter. You can take any radius, but it should be a fixed one. So I have taken this line segment, small line segment, and I have drawn this arc. And then I will be repeatedly shifting the position of this line segment and drawing 4 more arcs. So this is the second one, the third one, fourth, and this one is the fifth one. Number 3 point. The points where the third and the fifth arcs cut the ray AT are named as X and Y respectively. See, this is the third arc, and the point where this third arc is cutting this ray AT is named as X, and this is the fifth arc, and this point is named as Y. Now we join the points B and Y. The points B and Y are joined. This is B and this is Y. So the points B and Y are joined. Next, what we do is, through point X, that is this point, a line parallel to YB is drawn. YB is this line. A line parallel to YB is drawn through this point X, which meets the line segment AB at point C. So C will be somewhere over here, and that line XC will be parallel to this line YB. So how to draw a line parallel to YB through this point X? In order to draw a parallel line, a line parallel to a given line, we have to have that line and a transverse, so that we can get two alternate interior angles equal or two corresponding angles equal. In order to get two alternate interior angles equal, in this case we have to get the transversal as BX. So we have to join these 2 points B and X. I have not joined these 2 points BX because we are having a transversal. This ray ET can act as a transversal and YB is the given line. So instead of trying to make alternate interior angles equal, we can make corresponding angles equal. If we take this transversals, because we will be having this transversal is making an angle with this YB, this is the angle. So if we have to make corresponding angles equal, we can only make corresponding angles equal. Otherwise, if we want to make alternate interior angles equal, the other angle will be on this side of the ray AT. And the line parallel to YB will be drawn on this side, which we do not want. So we will be making equal corresponding angles. For that, we place the compass needle at point Y and with any suitable radius, we draw an arc. So this is the arc, and this arc cuts this ray AT at point P and the line segment YB at point Q. And this is the radius. YP is the radius. Now we place the compass needle at point X, and with YP as the radius, we draw an arc. This arc cuts the ray AT at point R. Now we place the compass needle at point P and we take the radius as PQ. This is the radius that we take. And next we shift the compass needle to this point at point R, and with the same radius PQ, we draw an arc, which cuts the former arc at point S. Next, we join these 2 points X and S, and we extend the line to meet this line segment EB at point C. So this is our required point, this point C. AC is to CB equal to 3:2. The ratio between the lengths of this AC and CB is equal to 3/2 or 3:2. Now we have ended our construction, but we haven't given any proof for our construction. So coming to the proof part, since XC is parallel to YB, XC is parallel to YB by construction because these two are corresponding angles and they have been made to be equal by construction. Therefore, XC is parallel to YB. By the basic proportionality theorem, since XC is parallel to YB, therefore by the basic proportionality theorem, we have AC by CB, that is EC by CB, equal to EX by XY. And what is EX by XY? You see, we are having 3 arcs. Starting from this point A and coming to this point X, in between there are 3 arcs. So I had placed the line segment thrice in order to come to this point X from this point A. And in order to reach this point Y from this point X, I had placed the line segment twice. So EX by XY or EX is 2, XY is equal to 3:2 or 3/2. I have not written it in a ratio form because for the basic proportionality theorem we write it in this form. So I have written it in this form. AX by XY is equal to 3/2. Hence AC by CB will also be equal to 3/2. That is, AC is to CB equal to 3:2. This is how we divide a line segment in a given ratio. The only thing that you have to remember is how many arcs have to be drawn, and that is given by adding the two numbers present in the ratio. Okay. So students, this brings us to the end of this session. Thank you for hearing.